This is a 3 elements vertical yagi antenna for the VHF 2 meter band. The antenna is designed to operate from 142 to 148 megahertz, but this can easily cover 140 to 150 megahertz. So let's check the antenna configuration. We have the mounting bracket. We have the elements holder attached to the boom. So I just need to put back the corresponding elements with their numbers on the boom. So I'm going to put the numbers on each element and on the boom. So you just need to put back the elements with their corresponding numbers on the boom. The antenna has an option for mounting it at the middle. So I just need to put the mounting bracket here, and you can use it as a mid-mount antenna. We have an SO239 feed point attached to the gamma match. We have the tuning stub positioned 1 centimeter from top of the gamma match. I put a marking tapes, so you just need to put back the tuning stub in between those marking tapes. Make sure that you tighten the SO239 nut so there's no loose connection between the boom and the SO239 feed point. We have an RG59 coaxial cable as our pacing harness, cut in 1/4 wavelength multipool. So this is an impedance transformer to convert the 2 coaxial cable to 50 ohms impedance. Make sure that you tighten the connection of the SO239 and the PL259 connector on the antenna on each side. Making sure there's no loose connection when you are installing the antenna. So we have the same configuration on the other side. The gamma match is positioned 1 centimeter from the top of the gamma match. We have an SO239 feed point, same construction with antenna mounting the elements holder. So let's check the frequency response of this antenna. This is now connected to a T connector going to the RG8 coaxial cable attached to my antenna analyzer. So we have the center frequency on the antenna analyzer. After the antenna analyzer testing, we will confirm the settings or the readout of the antenna against the ISO 2900 on high power settings with an SX400 SWR meter. So let's check the frequency response of the antenna for the 3 elements yagi. On the center frequency, we have center frequency is 144. We have the resistance at 49.72 and the impedance at 49.69. We have reactance at 0, so we are at resonance with 1.0 SWR, almost 50 ohms impedance with an antenna returns loss of minus 40 dB. Let's move to the center frequency because my crazy cat is playing with my antenna analyzer. So let's move to the center frequency. Our S11 is minus 45 dB, the antenna return loss. BSWR is 1:1 at the center frequency. Resistance is 49 ohms and impedance is 49 ohms. We have 0 reactance, so we are at resonance. So let's go down and check the other frequencies. 143 is 1.2, 142 is 1.4, 141 is 1.5, and 140 is 1.6. So let's go up. .146 is 1.4. Let's check 145 first. 145 is 1.2. 146 is 1.4. 147 is 1.5. 148 is 1.5. 149 is 1.6. And 150 is 1.8. So that's less than 2:1 VSWR across, from the frequency across 140 and to 150 megahertz. So let's check the frequency curve. So this is the antenna return loss or antenna return coefficient, or S11. We have center frequency 144. We have the antenna return loss at minus 47 dB. So let's move the cursor to the VSWR curve. So let's enter. So this is the reactance at 0. That's the resistance at 49.83 ohms. Impedance at the same. And the VSWR curve from 140 to 150, we have less than 1.6 at around 140 and less than 2:1 around 150 megahertz. The center frequency is 1.0 or 1:1 VSWR. So let's compare the readout from the antenna analyzer to the VSWR meter and the ISO 2900. I have now attached the antenna to the ISO 2900, connected by a patch cable to the back of the SX400. This is the antenna feed line, still connected to the antenna via the T connector and the RG59 pacing harness for our impedance transformation. So let's check the VSWR response of this antenna. So we need to set the radio on high power. So the high power would be around 60 watts because I adjusted this radio. So let's calibrate the VSWR meter. So we are set on 200 watts. So we need to zero the readout on the VSWR scale. So 144. Let's move the switch to SWR position. We are transmitting and our VSWR is 1:1 on 144, same as what we see from our antenna analyzer. So let's check other frequencies. Let's move to 143. So let's recalibrate. So that's already 0. We are still on high power. So 143 is 1.1 from our SX400. Let's move to 142 and let's recalibrate. So we need to adjust the needle. So let's switch back to SWR. So as we can see, we have 1.3 on 142 megahertz. Let's move to 141. Let's recalibrate. So we have need to adjust the needle. Still that's 0 now. So let's switch to SWR. That's 141 at 1.4 or almost 1.5, but still it's 1.4. From it's in the middle of 1.4 and 1.5, so around 1.5. So let's go to 140 and let's recalibrate. So we need to adjust the needle to full deflection and switch to SWR mode. So we have 1.6 as we can see on the BSWR meter. So let's go to 145 and recalibrate the BSWR meter. So we need to adjust. So we have full deflection, switch to SWR mode. So we have 1:1 or 1.1. That's 1.1 on 145. So let's go to 146. Let's recalibrate a little bit. So it's full deflection. Full deflection. So switch to SWR mode. We have 1.2 in between of 1.2 and 1.3 on 146. 147. So let's recalibrate, set it to full deflection. We are on full deflection, so switch to SWR mode. So we are 1.4 on 147 megahertz as we can see. Let's go to 148. Let's recalibrate. So we are on full deflection, 148. So we can switch to SWR. So still 1.4 on 148 megahertz as we can see here. Let's move to 149. Let's recalibrate. So we need to adjust the needle. So we are on full deflection at 149 as we can see here. So let's switch to SWR mode. 149 is about 1.6 BSWR. So let's go to 150 and recalibrate the BSWR meter. So we are now on full deflection. Switch to SWR mode. So we are 1.8 BSWR on 150 megahertz. So let's recheck 144. So let's recalibrate. We're going to test the power output of the radio. It's on high power. We are on full deflection. So switch to SWR mode. Still 1:1. We are transmitting 1:1 BSWR. So let's check the power. Let's press the radio. So as we can see, we have 60 watts on the 200 watt settings. It's 60 watts on our VSWR meter. So reflected readout is 0 and forward is 60 watts on 144 megahertz. So this antenna is properly working and is now ready to ship, going to my neighbor here in Atimonan, Quezon. Thank you for watching. So this time, let's recheck the frequency response of the same antenna to stock 3 LMS vertical yagi against the nanoVNA. So we have the same antenna configuration, same pacing harness, and the coaxial cable now attached to the nanoVNA. So I'm running on a power bank because the battery of the nanoVNA is not that good. So our frequency span is 140 to 150, or the frequency SIP. We have 10 megahertz span. We have 10 points per division between those lines. So from the first line to the second line, it's 10 points per division. We have current frequency is 147.9. So let's go to 148.450 or 148.5. So 148.5 SWR is 1.5 at minus 14 dB with an impedance of 34.5 ohms. Let's go to 147. Because these are the intermediate frequencies that will be used on this antenna, that's why I'm checking it. 147 is impedance is 37 ohms at 1.5. Let's go to 146. 146 is 1.4. Impedance is 49.6. So let's go to the center frequency and just read the bottom frequency response and the upper frequency 150 megahertz frequency response. So we are on 144 megahertz. Impedance is 49.8 ohms or 50 ohms. Our antenna return loss is minus 32.34 dB. Our SWR on the center frequency is 1.04. So let's go down to 140. So we have 140. Our frequency of interest, we have SWR of 1.6 with minus 12 dB antenna return loss. Let's go up. So that's 150. We have impedance of 61 ohms. Return loss is almost the same at 12 dB. SWR is 1.71. So we have pretty much the same reading between the N121SA antenna analyzer, the nanoVNA, and the SX400 VSWR meter. So this antenna is pretty much working with less than 2:1 VSWR across the band 140 to 150 megahertz. This antenna is properly working and is now ready for shipping, going to my neighbor And that's it. Thank you for watching, and until next time.